can't hear, sorry. Hey, good morning. Welcome to Azure Flash News. Happy Friday.
Happy Friday indeed. Long weekend in the U.S. It's gonna be nice.
Yes, it is.
You got
Yes,
any
it
big
is.
plans?
Lots of stuff to get,
Yeah.
lots of stuff to get caught up on. Yeah, this echo is throwing me off. I muted the office button, but this echo is. Anyway, it's all good. We're not going to worry about it because we can do that. Yeah, we've got some great announcements today. So as you guys are aware, we have moved to GitHub for our source repository for our show notes and all that goodness. So thank you. And so we've got a good thing going on here. Oh, I had unmute. See, is the interface between the chair and the Okay. So we've got some good stuff today. We've got an announcement around load balancer and some things we're doing to enhance that. We've got some new edge site locations, one of which is really exciting for us. New cloud regions. Yes, I know. Just when you thought Microsoft had enough regions, here we go again, baby.
Can we ever have enough?
No,
Yeah.
no. And then we want to do, there's the Azure Maps and the location of things instead of the Internet of Things. We've got the location of things.
Mm-hmm.
And I went ahead and we're going to do a demo today for you. I went ahead and maybe did a few tweaks to it. So having said that, thank you for joining us today.
Yes. Yeah.
Greatly appreciated. Let's jump right in. So Azure Load Balancer, Azure Load Balancer becomes more efficient.
Yes.
Okay.
Yep.
So when we talk about load balancing, when you think about load balancing, what comes? I mean, when you think about that, I mean, different people have different. So, and the reason I'm asking you this, I'm not trying to put you on the spot. I'm asking you this because I've run into this situation with customers where we talk about load balancing, and some customers think about it like a layer 4 type of situation.
Oh, I see what you're saying.
Some customers think
Like
about
layer
it layer
7.
Exactly.
Yep.
So when you hear load balancing, what do you think? I mean, what's your?
Well, I guess typically from an infrastructure perspective, I would look at that layer 4 perspective. But you know, if I was having a conversation with a customer or with other people about the load balancing technologies that Microsoft brings to bear, I think that we have a slew of them, whether it is the load balance that we're going to talk about, App Gateway at that layer 7, or even things like Traffic Manager that are using DNS to do load balancer, or Azure Front Door using Anycast IPs in order to route you to the correct place. So,
which is awesome.
Yeah. Oh, it is. It is really great, really great. But so, I mean, yeah, I think that load balancing, you're right, could mean a lot of different things. In this case, we're specifically talking about load balancer, Azure Load Balancer.
Yep.
And what this announcement is really getting at is that with the standard SKU, they did make some changes back in 2017.
Correct. Yep.
And now they're rolling this out to all Azure load balancers that what we have.
Which is awesome, right?
Yeah.
And the cool thing about this is because it's software-defined networking, right? When we make a change, we're not going into every single region, every single data center, every single rack and replacing a switch and replacing. It's not a physical equipment, swap that we have to do. This is software-defined networking. So basically, we're pushing out code.
Yeah.
And I know that sounds scary, and yeah, that's not without some, potential hiccups. But at the same time, when you think about 54 regions and you think about the number, I mean, oh my gosh, the number of places and locations and devices that we would have to swap out and configure, and oh, well, good Lord. So this is you can see the power of software-defined SPLAT, right? So software-defined networking, data centers, infrastructure, whatever it is. So so we've got some cool things. Okay, so basically we're bringing some advantages from the standard load balancer, right? So it's more predictable and efficient outbound connectivity management, right? And that's a big deal. So outbound connectivity is basically we're talking about SourceNet or source network address translation, right?
Yep.
And so basically we can use one or more of 3 scenarios for outbound connectivity depending on the deployment model, the resource utilization, and how it's configured.
Yeah,
right?
well, and just to get into what those 3 models are, so you could have a VM with a public IP address, and so whether it has a load balancer or not, that public IP can do outbound connectivity using SNAT without port masquerading. And then you have the model that we're talking about here, which is with a load balancer. So no public IP address on that VM, but sending its outbound connectivity through a public load balancer. And that's going to use this port masquerading technique that we're talking about here. And then you can have a VM with no load balancer or no public IP but it can still get outbound with SNAT, with port masquerading. It's just not going to be forced through that one egress point. That's going to be using the Azure Fabric in order to get out,
send
you know,
it
for
out.
things like out,
Yeah, so
updates, things like
so
that.
basically, you're not essentially, you're not defining the route, outbound route to go back through. You're basically saying go out any one of these different.
Yeah. Yep.
Okay.
Yep.
Awesome. And so basically there's differences clearly you're talking about. So we've got differences between the legacy and the new algorithms that we're using for SNAT. And there's a great table that does a side-by-side comparison. So before 2017, services that were deployed used the legacy SNAP port allocation. And after 2017, using the standard SKU, you're going to use the new allocation, right? So in the pre-allocation, you've got, let's see, smaller number tenants for SNAP port allocation. So there's different backend instant counts, ephemeral port counts. It looks like we've got a bunch of different U-bound limits, that kind of stuff.
Yep.
Maximum number of ports, we've got different limits there.
And so really what this is getting at, I think, is that one of the problems that you can run into with address translation or port masquerading is that you can exhaust that number of ports that you have.
Right.
And then what ends up happening is that you have outbound connections that don't have an ability to go anywhere.
Right.
And so what we're doing is we're opening up and allowing, you know, you to have more visibility, more control, as well as giving you more, when you're talking about that pre-allocation, we're giving you more ports just right off the bat for you to be able to see.
Which is huge, right? Because basically, so that to that point, I know basically there's 65,000 some ports, but there's a significant number of them that are reserved, right? And then on top of that, we weren't necessarily, were we giving them all 65,000, or were we historically, or before we started doing this, so help me understand what the kind of the changes there then?
Well, so I think that really what it's getting at is that's actually a great question. I don't know if all of them are available or not initially, but I think that what it's getting at is that you will have less of a chance because we're providing you with 1,000 different ports. So I think when it's saying that they were pre-allocated at 160, that's where you started, and there could be a time up to spin up to get to that.
That's
number.
what I'm seeing.
And so that's why you would want to pre-allocate.
Yep.
And then the other thing that you're getting is when you're doing scale up and scale down, you can see that there's much more clear distinctions about how that's going to happen with those ports.
Yep.
And so you can understand what the impact is going to be. And so you can see in the use cases, I think, really what this is getting at. So with the older model, if you had a noisy neighbor, it could take all of those available ports. So those 65,000 ports are shared across all of your instances. And so if you have multiple connections outbound from one instance, well, say that you have something go awry, it could consume all of those allocated ports. And as you're scaling up, it can continue to consume all of those.
And that's what I was just looking at. So port reallocation is done in scale up, but existing connections might drop on reallocation, where in the new way of doing things, that doesn't, so port reallocation is done, but existing connections, so the ports are all allocated to the new instance, which is interesting. So the static ports are always allocated to the new instance, whereas before port reallocation is done and then the existing connections might drop. But if the backend pool is changed, then the ports are exhausted, then the reallocation is done. I'm making sure I'm reading that correctly.
Yes.
Wow, that's crazy.
Yeah. So so I think that the real key is that we're just trying to give you more visibility, more control.
Yes. That's huge. So noisy neighbors, to your point, that's exactly one of the big issues. Is you're not necessarily getting dinged by that.
And so I think that the one of the big things to call out, because you were talking about the software-defined networking, this rollout process. So this is a platform feature that's being rolled out.
Yep.
So we are handling the change. There's nothing that you have to do, but there is always some slight risk to change.
Of course.
And so we understand that there will be critical workloads, things like that. If you do have something that's using a load balancer and you're worried about when this change is going to roll out, you can always open a support ticket in your Azure portal. And they've got instructions on how to do that in this document and how to route it properly to make sure that you get that information to the teams that are rolling this change out so that they can inform you of when the change is going to go to that work.
Perfect. That's awesome. Okay. And technically, so in the small, basically what I'm seeing is in the small number of customer deployments which are using a higher number of snap ports, there might be a temporary drop of a piece of or a part of the flows, but it should autocorrect within a few. But
Yep.
I think it's just you want to be aware of when the change is going to happen, so you can monitor that to
Yep.
make sure that
Yep.
autocorrect happens within that few seconds.
Yeah.
Awesome. Very cool. Okay. So yeah, that's so it's all about basically extending, enhancing, building up muscle, giving customers flexibility, freedom, opportunities to do things differently, that kind of stuff.
Yeah.
So,
Yeah. Absolutely.
very cool. So that's great. That's a great update. It's good to know that we're really moving forward in that direction and taking that standard the offering with that standard load balancer and bringing them to these other.
Yeah.
Very cool. Awesome. Well, speaking of networking,
Yeah.
so this one's interesting, right? So sorry, I scrolled down. So latency is the new currency of the cloud, okay? And yeah, right? I mean, when you're deploying things, you absolutely do have control over where they get deployed into, where they get provisioned into. But at the same time, you've got region-to-region deployments. You've got, you may have things that are deployed into a specific region because of VM constraint, size, SKU constraints. It might be because you are in a preview that's doing something that's not available everywhere. Or it might be, getting into the Azure, getting on the Azure backplane, right? And so basically, we're announcing 31 new Azure Edge sites, okay? So Edge sites, basically. So the first thing, let's talk about latency. So latency, access, and cloud services can be an inhibitor, right?
Sure.
Again,
Absolutely.
if you've got, especially if you've got time-sensitive workloads, commercial internet connections go through a whole bunch of different pops. You don't necessarily have a guarantee in terms of how many different jumps it's going to take before it finally gets to basically Azure.
Yes.
Right?
Yep.
And so in that case, what we need to do and what we're doing with these edge sites is we're distributing and deploying all these locations and more of these. So the goal is to get the least number of hops before you hit Azure.
Right. Because once you hit the Microsoft Enterprise Edge, you will use our backplane to connect to all those services wherever they are in the world. The other thing that you get from the edge, from these edge sites that we're announcing, is some of our caching technologies and some of our networking technologies that allow you to really utilize that Microsoft network. So the Azure network, it was, is a Microsoft Enterprise network. So we built Office 365 using this. We've built Azure using this. The Xbox Live network uses all this. So we have customers throughout the world that rely on this network, and we're providing the same connectivity for you to be able to have your customers use your resources, but using our network.
Getting on our network. The goal is just to get on as fast as possible.
Yes.
Ride our backbone.
Yep. And so what we're talking about, though, is that we're giving you the ability to use Front Door in these new locations, which Azure Front Door, we mentioned that briefly, is an awesome technology that we offer to our customers that allows you to accelerate the deployment of your applications. And then you can also use things like Azure CDN, Content Delivery Network, for things like blob storage or web applications, video streaming, things along those lines. You can combine those two technologies. Azure Front Door has some of that caching from the CDN built in.
Right.
And then we're also talking about express route connectivity.
This is the one that gets me excited. The other ones are really important, but this is the one that gets me really excited because, when you think about express route direct, and you can get up to 100 gig, right? And then you can get the 100 gig ports, and it's like, wow. And then take these new edge site locations, and you're talking about some pretty considerable performance.
Yes.
I mean, this is not your father's Oldsmobile we're talking about. This is we're talking about a Tesla.
Yes.
At a minimum.
Well, and so I think that one of the things from like a statistics perspective that they call out is with this new expanding network of edge sites, we provide more than 80% of the global GDP. Wow. So it's not necessarily 80% of the global population, but where your customers are, and where that is with sub 30 millisecond latency. So that is an amazing number when you think about it.
That's
huge. And we continuously expand this network of edge sites. We're continuing to deploy this with the hope, we want to enable everyone to achieve more at Microsoft.
Of course. Absolutely.
And so we are continuing to expand this to allow the entire globe to be able to have this level of connectivity. So you'll continue to see more and more points of presence throughout the world to enable these capabilities.
So this brings the total to over 150 edge sites across more than 50 countries. But in addition to that, we're also announcing 14 new Meet Me sites for ExpressRoute. And so that's part of that ExpressRoute announcement we just talked about. And so that's a big deal, right? You get expanded access to these private connections between on-prem and Azure. But what really gets me excited is, So if you go and look, we've got a nice table that talks about the new edge site locations, the different countries and the different cities. Obviously in the US, we've got Boston and Portland, but what gets me happy is the upcoming edge sites. If we scroll down, you'll see in the United States, Minneapolis is on that list. So just in case you can't see it, let me zoom. And look at that.
There we are.
Yep. So that's super exciting. So that is, I don't know, can we say where it is, or is that super secret?
I'm not sure if that
okay,
is
we're just going to keep,
yeah.
let's just say it's in Minneapolis.
It's in Minneapolis,
so
yeah.
When you think about, the opportunity now to get on the Azure backplane right here in Minneapolis, and then, so you've got secure connections, you're not traversing the public internet, you're reliable, you're dedicated, you're consistent, you're, I will say, predictable in terms of performance. This is huge. This is huge, 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 huge. So in addition to Minneapolis, we've got Detroit, Jacksonville, Las Vegas. So apparently when I'm doing my gambling, I can
really connect fast. Yeah.
Wow, I can lose money really fast. We've got Nashville, we've got Phoenix, we've got Quincy, Quincy, Washington, which is where we have one of our regions, and San Diego. So I may have to go and physically inspect the San Diego location just to
probably
make sure,
around that January time
just to make sure it looks good and everything's hunky-dory there. Yeah, absolutely. No, that's super exciting. I mean, wow, this is awesome. So we're just giving you more locations and more connectivity points to hop on the Azure backplane, to traverse our fiber, our dedicated fiber, right? Not unlike some of our competitors, they force you to traverse the public internet unless you establish VPN connectivity between locations. We don't do that.
Right.
This is really, really exciting. So if you're in this space, take a look at the new locations, get prepared, get ready to look at that meet me point. If you weren't deploying express route because you were concerned about the next location for that, look no more, worry no more. It looks like we're coming to a theater near you.
Yes, exactly, yeah.
Cool. Awesome, awesome, awesome. Okay, Switzerland. This is another place we may have to go do a physical inspection of the data centers.
Yeah, I haven't been there in a while, and it's beautiful there.
So I haven't been there ever.
Oh, well, you should go.
I should go.
Yeah.
I keep hearing that. What's really cool, so we've got 2 regions in Switzerland, because generally speaking, as our listeners and viewers know, when we deploy a region, typically we deploy 2 so that you get the redundancy, right? The pairs, right? The geo-redundant pairs. With the exception, of course, of Brazil, South America, because we couldn't find an efficient, cost-efficient, reliable. Anyway, so we've got 2 in Switzerland, and the interesting thing about this, though, is as I was reading through this blog post, I was looking at the customers that were called out. Okay, so we've been operating in Switzerland. We've been operating for 30 years. Azure is now available for these data center regions near Zurich and Geneva. Okay. 30 customers and partner orgs are already using these new Azure services. So they were on a private, super top secret preview kind of thing. But what's really interesting is UBS Group, the world's largest wealth manager, okay, money.
Yep.
The Swiss Re Group, reinsurance, insurance, Swisscom, telecommunications. So you're seeing a broad swath of different types of companies that are using these capabilities. But these are traditionally risk averse, not necessarily the telco space, but when you think about insurance, when you think about financial industry, they are generally speaking, I would say, and I don't mean this derogatory, but they're laggards when it comes to adopting the cloud and because there's concerns about hosting and all that other stuff. But what's interesting is when I think about Switzerland, I think about banks, right? And I don't know why, but I always think about, that's where, no, I'm not even going to say it because I'll say it and somebody will tweet it and the next thing you know, the IRS. I was going to make a joke about that's where I take all my offshore money and put it there. I don't. I joke. But, that's kind of always what you associate Switzerland with how people, they hide their money there and all that stuff. But yeah. It's really cool though that you've got this opportunity in Switzerland with these banks, with these insurance companies, hopefully with the watchmakers as well.
Yeah, well, I think that there's 2 interesting things to call out about that. Is that that a lot of those companies that you're talking about, they care a lot about compliance, and that's why you're seeing us roll out a lot of these region pairs in a geopolitical boundary like this. So if there's a new data residency requirement and things along those lines, Microsoft continues to make investments to ensure that we're able to help you meet your compliance standards.
Yep, absolutely.
And we have over 91 compliance certifications, I think, today. So so we continuously invest in this, and that's, I think, why it's impressive that we've had adoption. So that's why that's why we have two in Switzerland. And that's why I think that you're able to see all of these financial institutions or these companies that might have those compliance certifications come to Azure because we're providing them with that.
Absolutely. Absolutely. So yeah, this is exciting. If you're if this is a regional deployment location that you've been waiting on, wait no more.
Yeah.
Because now we've got Switzerland. And with the new edge site locations, with the new Meet Me, man, oh man, we are kind of taking over the world.
Yeah,
we'll
continue to expand.
At least from a footprint perspective.
Yeah, we'll continue to expand and continue to provide you with the compute and network and storage in the areas where you need it.
So this is interesting. So before we hop off this though, they changed the format of all this. I was going to kind of click. Usually there used to be kind of an at a glance kind of look at where we have all our compliance and certification kind of thing, right? Current compliance offering. Oh, and then you got to look, now they make you filter it and all that stuff. But so you can see all the different, so global, government, industry, regional. I'm just slow scrolling through this list for the listeners. I mean, this list is significant, right? I mean, it's pretty crazy. And we just constantly are adding new certifications, new attestations. It's nuts. So if you're ever curious about, you can go to the Trust Center. If you ever want to know what our most up-to-date compliance offerings are, you can go to the Azure Trust Center at, in this case, it's www.microsoft.com/ I don't know if you have to put this in, en-us/Trust Center, and that'll take you into that space.
And the other nice thing about the Trust Center, just to stay on this topic for a little bit, is that you will also have compliance requirements that you have to undertake for your workloads.
Yes.
But we actually do a really good job, I feel like, of walking you through. Here's what Microsoft has done to provide you with to get this attestation and to provide you with the comfort that we have that level that you need for your compliance. But then here's what you still need to do to ensure that your actual workload continues to maintain that level of compliance. Because that's never going to go away for you.
No, it's a shared
responsibility.
Yep, exactly. Absolutely. No, it's a great point. Okay, so this takes us kind of to our last blog post of the day. So I started going through this earlier this week, harnessing the power of the location of things with Azure Maps. Okay? So I started playing with Azure Maps a while ago, was doing some fun stuff, canvas drawing, doing different layers, just kind of, and it kind of mothballed it for a while. And then this came up. So I was going through this blog post and was looking at it and saw geofencing. I thought, oh, this is kind of cool. We've got some shipping and logistics customers in the Twin Cities. There's obviously, I think it's pretty well known. I think we work. I want to say Tom. Yeah, because I was just clicking on this image here, and if you look in the bottom corner, there's Microsoft, and then there's copyright. It's a little fuzzy now, but it says Tom. So a lot of different scenarios. We've got some really cool, interesting things about route optimization, about traffic. So we're building up this corpus of capabilities within the Azure Maps space, right? So I started looking at this article, and it talked about basically tracking a sensor, which phones home, and basically register it with IoT event hubs, and then checking to see if it breaches a geofence. I'm like, okay, I think I'm going to go through this. So I walked through it. There's a great link. Let's see if I right here, implement IoT spatial analytics using Azure Maps. So I started going through it's a read through, but you can follow along with the tutorial. So I started going through, and so you create an IoT hub, okay? You basically create a JSON payload, a geofence area that's already pre-built. It's in GitHub. You can go grab it and deploy it. What it does then is it returns a UUID that you can then use as basically an identifier to determine whether or not something is out of that geofence. Okay. So you create an Azure function, which basically implements some logic based on when information lands to determine that function will use the spatial analytics available with Azure Maps to determine if you're, because it makes a call and says, here's my location, is this
Okay.
Right?
Okay.
Then you've got IoT telemetry events from that function via event grid. So it's wired up to event grid, and it takes those events and basically filters that using message routing. Okay. So what they were doing though is they were storing this information in files. So if a device was out of that geofence, it would basically create the like lat launch time address, because it did a reverse address lookup and said here's the basically the address of that location. And it was fun. So I went through and I had built out the solution, and so you can see kind of the high level architecture. And then I got to this. Oh, where is it? No. So I went. Okay, keep going. So we went through all this stuff. Found a few things that I've got a made note of that I'm going to follow up with the authors on, or just do a pull request.
Absolutely.
Do a pull request and see if I can update the content. And kept going, got through this stuff. It was fun. I was having a good time. I was wiring up the event grid, created my Azure function, did all this fun stuff here, tied it to the storage account because it's grabbing it, writing it to storage while it's doing the lookup. And
so does it actually trigger off of the blob right to storage?
Or the event hub. The IoT
okay.
event hub basically takes in the information. When we hit that message basically gets that function basically grabs it, looks up the information, says, is it in fact in or out? If it's not, in this case, it was saying if it's not out of the geofence, discard it. I made some changes to say keep it anyway. But then, so it takes that and it uses that IoT. So then it puts that on the event grid, basically routes it to the event grid, which the function grabs it. And then, so if we keep going through here though, so here's the map. So I got to this point, right? So I've got this payload. I was looking at the data, and then I got to this point. I'm like, okay, so that's a cool visualization. I like to play with Azure Maps. What the heck? Where's the instructions on how to display this? And they weren't there. So what I did was I made a few changes. So in the rental car simulation app, what it does is it takes this, there's a geofence, this is that geofence information that you grab, or that I put in there. You can go grab it on GitHub. And then here's the route data. So this route.json file basically simulates a path or a route for a vehicle.
Oh, very cool.
And so it travels around within the geofence, geoboundary, and then it goes out of bounds. Okay, and as soon as it goes out of bounds, basically it starts collecting that information.
Okay.
Well, I extended it a little bit. So what I did was I took a logic app and I incorporated basically an HTTP endpoint for the logic app and said, if this happens, send me an email. Okay, so I get emails if that car were to go out of the geofence. The other thing I did though was instead of writing this information to a file, because what I wanted to do is I wanted to display it, but each incident or each location where it phoned home and it was out of the geofence basically wrote a new blob file.
Sure. Okay.
And to actually to go through all these blob files, collect that information, display it on a map, it seemed like it was a little bit tedious. So what I did was I reworked it just a little bit. So you can see in this particular case, I've got, whoops, I'm in the wrong. Load my subscription. Come on. Okay, there it is. Come on. Takes the longest, but so what I did was I went ahead and I collected the information, but then instead of persisting it to Azure flat files, I actually persisted it to an Azure table.
Oh, very
And what
cool.
I did was I created a partition key that I created, which is called basically a trip. So for every trip the car makes, that's a partition key, so that you can collect, you can basically group them by partition key. And it looks like this is taking a little bit, so I'm just going to keep this closed for now. But so now what I do is in the web app, if we go to my view, and I was lazy, I dumped this in the shared location. So if we go to my layout, okay, and I scroll down, what I did was I created the map, using the map control that you can get with Azure Maps. And on the ready event, what I do is I create 3 sources. I create the geofence information. I create the push pin data for each one of those locations that it reports.
Okay.
And then line data, which draws a line basically from pin to pin.
Okay.
Yep. And the other thing I did though was the actual information though was, so I do still get the geofence data from that JSON file because that's the file I use to upload it. Doesn't change, it's static, et cetera, et cetera. But I also wrote a controller that in a tables controller called get trip lines and get trip points. So what this does is I pass in the trip ID and the vehicle key. In this case, I only have one vehicle. It's called vehicle device, and it returns the data in a GeoJSON compliant format.
Okay.
To be able to present it on the map. So if the demo gods are smiling, let us see if we can present this information. So remember, there were only 3 points. So if I go back here and look at this, there was only these 4 points because those were the ones that were outside the geofence.
Sure.
Okay.
Yeah.
What I did was I turned the flag off that said, if it's outside of the geofence, save the information. I turned that flag off and said, capture the information regardless. So you can see here, this is the entire trip. So the trip starts up in here. So this is a map of, this is Washington. And the trip starts up here. And you can see all the different points that were collected. And then bam, this is where normally you would start to see those outbound or those geofenced alerts kick in.
Okay.
So as soon as it hits this point in the simulator, I start getting email alerts saying your car, this vehicle is out of the geofence.
Very cool.
Yeah. And so super simple. It was real straightforward to create. And the controllers were very, very easy to build. If we look at those controllers quick, I will go to my, where is it? My tables controller, and I've got, oops, these are my views, sorry. My controllers, tables. I have to, so all I did, and real wonky, I wouldn't recommend this. I did it pure string manipulation. So I created a geometry collection, types geometries, points. I created an array of points, basically, pulled it in, just super wonky, super straightforward, but super simple to pull this from. You can see I did a table client. I pulled it from the vehicle key, which is the name of the table. So if you added a new vehicle, you'd have a separate table for it.
Okay.
And then the partition key would be each vehicle trip. So in this case, I just call a query, filter it by partition key, because, I mean, at some point you could have a list of all your trips, click on it, and it would show you that map. And then I just return all the points, latitude, longitude, and time, so that I can order by time, so that I get the correct path of the locations. And then I present it up on the map.
So this is something that, for the most part, other than the drawing piece you're saying, would be very easy for anyone who wanted to try to learn this stuff to follow along. And to
ridiculous,
follow the tutorial.
the tutorial was ridiculously simple to follow through. Super, super, super straightforward to implement this, everything but the map, all the guidance, so you can see here, this is the rental car simulator where it's going through, and here's all the different points it records up to a point where, boom, it records that it's outside the geofence. Sure. And then as soon as that happens, you can go into this blob storage, and if you see here, here's the payload. So this is what it was writing out to blob storage. So the device ID, here's the violation point. So that's where they did the reverse lookup to get the address. And then, of course, location and time. And I just took it a step further, dumped it into tables so I could grab them all at once, spin through the array, present it as dots and lines, and then draw. Yeah.
That's great.
Super straightforward. So if you're interested, I can certainly, this is all available in a GitHub repository that I can certainly grant access to. I can make it public. But super easy, super informal or educational way to register devices with IoT Hub, to start tracking information, to start taking paths with the data based on what's happening, right? Trigger those things and leverage Event Grid to surface those events to different, for example, you can surface Event Grid, you can wire it up and do really easy, what's it called? I forget what the parameter, the bindings, sorry.
Okay,
Yeah, the bindings, it just really demonstrates how easy it is to get up and running. I mean, literally just to build or to follow this example, it took me, I don't know, maybe an hour and a half to go through the tutorial. So yeah, if you're interested, it's easy to walk through. It's simple. You can make tweaks and changes like I did. You can set it up so it tracks every dot, records every dot, so you can see the full vehicle path, or you can leave it as is, and you can still see the geofence and then see the dots where the vehicle was out of the path. Yeah.
Awesome.
So anyway, that's my demo for the day.
That's great.
It was fun. It was easy. Like I said, I can make it available to people if they want to see it, go play with it, take the tires, that kind of thing. I'll obviously pull all the keys and secrets out before I do that. But yeah, there you go.
Awesome.
Yeah.
Great, Rick.
So that takes us, I guess, to the top of the hour.
Yeah.
And I guess, so to you, I will say, Tim, if anybody has any questions or wants to reach out to you, what's the best way to get a hold of you?
So you can get me via email at sullivan.timothy@microsoft.com, or I'm on LinkedIn, Tim Sullivan, one of the 3 that works for Microsoft.
Awesome. Great. And if you need to reach me, you can reach me at Rick, W-E-Y, at Microsoft.com, or of course at Twitter, or I'm sorry, at Azure Flash News on Twitter. Feel free to reach out, recommend us. You can catch us as iTunes, YouTube, Stitcher, Google. I mean, we're everywhere. So find your medium of choice. And if you like what you're hearing, like what you see, give us 5 stars, please. If you do not, let us know. We'd love to hear from you. Like to know how we can improve the show and make it better. Thank you very much. Thank you to the MTC. Thank you to Emily McMiller, our producer, who makes this happen for us every week. Without them, we certainly couldn't do this.
Right, definitely true.
Awesome. So as usual, we look forward to talking with the same time, same place next week. And until that point, please keep your fingers on the keyboard and your head in the clouds.